My name is Eric. I'm the director of the Southwest constituency of the Society of Spanish Researchers in the UK, and we are here just to, welcome you all to this first part of the Python webinar. Will be a series of 3 Python webinars, and this is the first online event we do this year, as far as I know, by the Society of Spanish Researchers in the UK. In this first part of the event, we would like to welcome you all, and then the second part will be just basically presenting the whole webinar, and at the end we'll have a Q&A session. So you can ask any questions in the chat below. You can ask any questions to everyone or to a specific person. You can just click in there, and then if we'll try to do our best to answer those questions as fast as we can. And yeah, so without waiting more, we will just introduce you to Dr. Luis Espinosa Anque. He's a lecturer at the School of Computer Science and Informatics in the Cardiff University, and we are very, very pleased to welcome him and then listen to his webinar. So thank you very much, Luis.
Thank you. Thank you, Eric. Thank you for the invitation. I see the numbers growing slowly in the chat room, so that's amazing. I'm just going to share my camera for a bit so you guys can see me, put a face on the voice behind the course. But I think what I'm going to do is switch it off again when I start sharing the screen. So this should work. Yeah. Hello, this is me. And I'm going to be with you for the next 2 hours or so. I think Eric, you need to enable the screen sharing thing because I don't have it. And once that's up and running, we'll give you a little bit of background. We'll tell you a bit about the context now of this set of seminars, and hopefully, yeah, we get you interested and engaged for today and for what's to come. So there you go. Yeah, okay, I'll see you guys after the seminar. I'm just going to share my screen now. Okay, so I should be sharing my screen, right? Okay. Okay, so let's give a little bit of context, no? So the idea for this course is to have, to provide beginner-friendly introduction to the Python programming language. And well, the awesome people behind the Society of Spanish Researchers in the UK have put it together, and because of the extremely exceptional circumstances we're all living in today, we have pushed quite hard to have something that can, that fits well in a remote environment, and what better than something computing related. So that's one reason. The other one is we're going to go into Python for a number of reasons. I hope at the end of the introduction I have convinced you about why Python is the best, and eventually give you enough tools to work your way with whatever use case is relevant to you, right? So it may very well may be the case that you're working with in an area like business or journalism, translation, number crunching like engineering or math. That's any of these areas fit very well with the Python programming language and the different frameworks that it has available. Before we started, I prepared a couple slides about me, so you know a little bit more about who is doing this beyond the fact that I work at Cardiff University. So this is. It's only going to be a couple slides, so I hope it's not too boring. So this is me. I'm Luis. You can hit me up on Twitter, and that's my personal website. And of course, Google me. You should see easily my Google Scholar DBLP profiles. And yeah, I'm one of those that got into tech through a quite longish journey. So as you can see, I've been around for quite a long time. I graduated in English linguistics in Alicante in Spain in 2006. And now I teach, the machine learning, AI, and computer science at Cardiff University. So you can see here, the kind of the journey I went through. Long story short, I was quite good at languages back when I was in college. I enjoyed that a lot, but I also was quite nerdy. I also like computers and video games. And to me, finding the area of research called natural language processing was really an eye-opener. So a career where you could mix your passion for languages and your passion for technology was something that was very, very cool. So I've been working both in industry and in academia. You can see several institutions and companies, and I'm mostly interested in terms of research in building semantic models for language, multilingual natural language processing. So I've been working quite a lot with Spanish and other co-official languages in Spain, like Catalan and Valencian, and yeah. I am one of I don't have a technical background. I don't have a STEM background in terms of my your BA, but I have been dealing with Python for my research and recently for my teaching quite intensively. So I hope this gives a little bit of context of who I am, and of course I'm very happy to explore research opportunities, career opportunities for those of you who may consider doing an MSc at Cardiff University. We've got a lot of excellent programs there. So, I mean, it had to be done, right? So shameless plug. And without further ado, I think we're going to move straight to the Python part because that's why we are all here, right? Okay, so that's me. And again, we are assuming that we said there was no requirement in terms of technical knowledge at all, so that was the whole point of everything. So in the description of the course, you probably saw that we said as long as you have a Google account and you have access to your Google Drive, that should be fine. What we're going to be doing today and the next sessions is going to use something called Google Collab, Google Collaboratory. It's an online version of something called a Jupyter Notebook, which is like a text editor where you can enter text, but you can mix text and code. And that's very useful for when you want to do prototyping or when you're building educational applications where you can mix your code and your nicely formatted text like you would do in a Word document and so on. So for today, let's think of today as a setup session, right? So we are not the interactivity that we're going to have today is going to be based mostly on this is a snippet of code. Can we figure out what the output of this code is going to be? And for that, you don't really have to install anything or to have one of these notebooks up and running. You can. It will allow you to do your own tests on your machine. But definitely make sure that you become familiar with this by the end of the session, or at least before we start our next session, which is not going to happen in anytime soon anyway, because then by then the degree of interactivity and different ways of solving same problem are going to be wider. No, so it's good to have access to this. If you were to do an introductory course on programming a few years ago without access to all these awesome tools, you would probably have to install the programming language itself if it doesn't come ready in your operating system. And if you were using Windows, for example, that was almost never the case. And libraries and your text editor of choice, etc., etc. And now this is, you know, we can build very powerful applications on our browser using Google Colab. So for those of you who want to follow, it's as easy as coming to your Google Drive folder. You can, it's in Spanish, but I will translate whatever needs translating. So you can have click on a new file, go to more. You may have to click on connect more applications and find Google Collaboratory here if you don't have it. In my case, I already have it because I've been using it before. If you don't, you just click on the plus sign, connect more applications, and that's it. You can do exactly the same by right-clicking here, anywhere in the folder, try to find Google Collaboratory, bam. And what you create is a notebook like this. Let's create one anew so you can see what it looks like when you create one from scratch. You have your Untitled notebook here, and código means code, texto means text, so we can add cells with code and with regular text. And we can combine these, we can move them up or down, we can delete them, and so on. So this is what the environment we're going to be using. They get saved automatically. We can rename them here, and it's really convenient. So no one will have any issue in running their first Python, their first lines of Python code if using this online environment. Even if you go online and look for tutorials on, you know, more sophisticated stuff, you will be amazed at how much you can do on your Google Collaboratory environment. I'm not really sure how much of, so this is a virtual machine. So every time we connect a notebook, we are assigned certain resources, hardware resources to our workspace. Here we can see how much RAM memory and how much hard drive we have exhausted. And these sessions last for about 12 hours or so, I think. So more than enough to start, you know, dealing with Python for the first time. Okay, right. And yeah, so if you hear me stuttering a bit, it's because sometimes I pop out the chat to make sure that I'm not missing anything. Depending on how many questions we get, I may be able to answer them along the way, or even better, wait until the end of the seminar. Okay, so let's cut to the chase. So I guess many of you will have already, while I was talking, exploring whether you had or didn't have Google Collaboratory connected as one of your Google apps. If you didn't, you probably already connected it. But again, for today, it's not mandatory because we are going to do mostly introduction to programming in general, and to understanding a little bit what's going on in a machine when we write code. But definitely have a look at it either today or starting tomorrow, because it's really something that makes life very easy, especially if we are starting to do our thing in computing and programming. Okay. So just as a forward before we start, we teach a large number of modules that intersect with Python and data analysis in one way or another, and at Cardiff Uni, either at the undergraduate and or postgraduate level. So much of the content that we're going to cover today has been co-developed with Matthias Treder, who is a lecturer in the school, and who has been it's been a treat to work with him in the last couple of years. Specifically, we've been teaching computational data science together. Okay, right. So Python time. I guess before we go into the first line of Python code, it kind of makes sense to stop a bit and ask ourselves why Python. We may already know that Python is a popular language, but why is that? Well, Python is a very powerful programming language, both in software engineering, like building, mobile apps, web applications, desktop applications, and so on. But also for data processing. So in the area of AI in general, but natural language processing, computer vision, reinforcement learning, etc. Python is almost always the preferred language. It has a very, 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 very big community behind it. So almost all scientific disciplines have their own sub-community working with the intersection between that specific discipline and Python. And it's quite easy to understand from the beginning. And we will see an example of this in a couple of minutes. So there are two types of programming languages, roughly two types of programming languages. One type is compiled languages like C or Java, and the flow, the process between writing code and having something happening in a machine is this, right? So there's part where the developer writes some code. That code gets compiled into machine readable code, binary code. That's typically another format. For C++, it's these .x files. And then that's what the machine kind of accesses and executes. There are other languages like JavaScript or Python, which are interpreted languages. And there are two main differences. One is that they have two modes of operation, script mode and interactive mode. And the other one is that the compiling step is kind of skipped. So under the hood, Python does the compilation step for us. So we have more direct let's say evidence of what we are doing in our local environment. So when we write code, we run that code, and that code gets automatically converted into binary code. That's what the machine understands. But this is something that gets obfuscated from the user, so we don't really see it, and we can focus on the development part. Right? The script mode is this. So we would have a text editor. It can very well be your Notepad app in Windows. We would write some code. Python would read our code from the first line onwards, so always from top to bottom. It run the instructions we have one after the other, and those would be run when we run this program, this script. They're called scripts. But interpreted languages also have an interactive mode. So this means we can go into an interactive console where we have single lines of code that get executed every time we type them, and the interpreter keeps track of the variables that we entered. So if our first line of code is myString equals hello, and the second line is print myString, the interpreter kind of remembers that the value of myString is this sequence of HELLO characters. So this is good for prototyping. This is good for basically anything else. The notebooks, and when we speak about notebooks, we're not speaking about the regular notebooks, but I'm going to use the term notebook for this Jupyter Colab type of notebook where we can mix both code and text. They are using under the hood this interactive mode. So this is why you will see that we will be able to access values of variables very, very late in our execution, even if we run those earlier, as long as we don't restart our environment. So we restart all the values of our program. Our notebook will remember what are the latest values for each of the variables that we're working with. Okay. But specifically, I said Python is popular. We use it a lot in research. We use it a lot for prototyping. There's a lot of code in production. Many of the apps we use every day in our phones, in our machine, in our computers are written in Python. But why is that? So this is not really intimidating, is it? Print data. Variable equals and then something. So it has a very clear and easy to read syntax. And believe me, this is not something that happens with that's not something that happens with all programming languages. So it's easy to get to get up and running with Python because the syntax is not intimidating. There are other reasons which may be a little bit less relevant for the sake of this introductory seminar, but they will become very apparent from the second one and especially the third one. Meaning it has a very intuitive object orientation. So I may say a couple things about this later on. It has full modularity, so we can kind of reorganize and rearrange our code whatever way we want. We will always be able to do, if we have a design in mind of how our program, our software should look like, we can definitely turn that design in our head into code with Python. It has a very good breadth of tools to deal with errors, bugs, data which comes in formats that we were not expecting, and so on. And this is, of course, a clear, a direct consequence of the first bullet point, is that it can be coded quickly because we don't have to write. So it's very succinct. When we have an idea, we can probably code it in Python very, very quickly because Python is very minimalistic. But on top of all these easy to use features, it's also very powerful. So it has an extensive pool of libraries. And when we say libraries in the context of computer programming, we speak about other software. So other software that we can adapt to in our code to do certain operations so that we don't have to write them from scratch. Of course, it runs everywhere. It plays well with other languages, so with the database of management languages, even other programming languages, and it has many advanced features. And this is also a direct consequence of the big community it has behind it. So it has many advanced features for dealing with language, many advanced features for dealing with numerical computations, many advanced features for dealing with images, videos, sensor data, you name it. And in case you were not convinced yet, okay, I see a question there, but it's been answered. So I think if you guys are having issues with the connection, with connecting Colab to your Google Drive, have a look at the chat because some of the answers may be relevant to you. So in case you're not convinced yet, This is a plot, a beautiful plot that shows the popularity of different programming languages over time based on the number of questions they get on Stack Overflow, which is like the reference forum for asking questions about programming. And as you can see, the popularity of Python in the 2010s decade skyrocketed, right? So definitely popular, and that's good because it means that whenever we run into a problem, it's very likely that someone else had that issue before, and it's very likely that that issue was asked in Stack Overflow. And yeah, no, so there's just to reiterate the importance of being minimalistic. If we wanted to write a program that shows some text in your computer screen, like for example, hello world, which is like the classic first text that we put in the first program that we write in when we're starting programming. This is what it would look like in Java. And this doesn't mean that this is useless. It's just that how the programming language is designed, it requires a lot of additional information before we actually write what we wanted to do. And that's not the case in Python. So in Python, we would simply write print hello world, and actually this semicolon, we don't even need it. Okay, so that being said, before we start, but I can see some Python here already, so we're very close to start. Before that, a little bit of, so you can see, this is another very nice feature of Google Colab. So this is an aside. Index means table of contents, and we can get rid of it or pull it out. And what you can see here is the sections and subsections based on the sections and subsections that I have been writing in the text blocks. So as you can see here, there's a bit on terminology, and then we start working with variables and types and how to name a variable and so on. So we're going to stop a little bit in terminology before we actually start looking at the different types of variables Python has. Right, okay, but before that, I think it's good, no, to maybe take a step back. And think what happens when we write code. No, what happens in whatever it is that we're dealing with that is likely to have some kind of software behind. Of course, this is a massive oversimplification of how computing works, right? But it's good to have like a broad idea in our head of what are the potential or the different aspects that a computer programmer typically needs to take into account when they write a program. And we're talking here about a full-blown program that does something specific and that probably is expected to do well in a variety of conditions and so on. So as I said, no oversimplifying things, but I think this gives a pretty good picture of what a program is expected to do or is expected to be able to deal with at any point. A program will need to get will need to be able to deal with input. Input can be user input. I don't know, maybe your password validation program in a website. The input is the attempt of the user in writing the password in the app. But input can be anything. It can be the stream of your video camera when you're maybe a program that detects faces in our video camera. The input is the actual feed, the actual sequences of frames or footage of our camera. A program is almost always going to generate an output. It's going to spit out some information. That information can be validation, true, false, valid, not valid, some data, or another program. Between input and output, there's likely to be some kind of computation. This is what we can think of it of the backend. So what's going on behind the scenes in websites, web applications, etc. However, not all computation happens all the time. There are certain bits of code that happen when some conditions are met and other parts of the code that happen when other conditions are met. This is what we refer to as conditional execution. And a computer programmer is expected to anticipate what are the different conditions under which his or her software is going to be put, and write code accordingly. And finally, repetition. So, so if you see that sometimes the formatting of these text cells gets broken, it's because if I do double click, I enter editing mode, but then I can just click outside and it goes back to the original rendering. And repetition, right? So it's a very common feat in computer programming, that there are certain bits of code that need to happen again and again and again, sometimes until a certain condition is met, sometimes for 5 times, for 10 times, and so on. Think of, I don't know, a vending machine where you want to get a can of soda. Coda has that can of soda has certain price. You throw coins into the machine. There's some software inside that's counting whether the amount of money we inserted is equal or higher than the price of soda. Because if it is, when we click on the soda button or the soda number, then the machine is going to give an output, right? So this repetition, this checking whether the money is enough to purchase a soda, is a very, very minimalistic example of how repetition is a very important thing in computer programming. Okay. So why is this useful for learning Python? Well, you know, no, it's not super important, but it's good to have a big kind of a zoomed out view of what a computer program typically is, because it kind of helps demystifying what we are dealing with. Okay, so time for terminology. So the plan for this webinar is the following. We're going to introduce different terms that are typically used in the context of the Python programming language, and do a few interactive examples here. In some cases, we will do things that we have not explained yet, but they should be sufficiently self-explanatory for you guys to follow along. And in any case, everything we cover will make sense at the end of the webinar. Okay, so we already know what variable is because we had one in this figure right here. But just to be a little bit more precise, a variable is a reserved memory location for storing values. And in other, let's say, more lay words, a variable in Python simply stores and provides data for the computer to do something about it. No, so in the statement A equals 1, A would be our variable, and a variable can have any name as long as we follow certain conventions, which we're gonna discuss later on. And this is and we're actually going to run our first probably ever line of code of this seminar, and for many of you this would probably be the first code ever. No, so here we declare a variable called my variable, and we assign it the sequence hi. Then we create another variable called migrate variable, and we say there, and we create yet another variable, our third variable, called space, and it's actually going to equal, it's going to have the value of an empty space. Now, with the print function, we print the content of whatever goes in round brackets to what this is called the standard output. This is simply printed to the screen. Okay. It's always going to be printed here. If you want it, I have the output already here because I already ran this notebook before we started, but we're going to run it again. So if I do my variable plus space plus migrate variable, I would get this. So as you can see, the plus sign here, it's actually concatenating the values of my variable and migrate variable, and my space, and then migrate variable. Okay, so to run this bit of code, click here, it runs. To verify that we're actually programming, we can change the value of our first variable, click on the play sign, the output is different. You will not see me doing this click. You will see me doing Control Enter. This allows this, that's exactly the same, and it's quite faster. So I prefer that. So Control Enter, there you go. Okay. Okay, so this is what a variable is. Another important bit of information that we want to be familiar with is the notion of operators, because it goes beyond the mathematical notion of operators. There are special symbols that represent computations. For example, the plus sign in 1 plus 2, so there's nothing special here. We've got also mathematical operators. Some of them are going to be self-explanatory, like the multiplication, subtraction, division, but also this one, which is the modulo or reminder, and this is the power. The power in Python is denoted with 2 asterisks. We also got other types of operators beyond the mathematical operators. We've got logical operators like and, or not, and we will see how we can use them in minimal use cases. But I mean, this is English, right? So we can probably expect what they are going to be doing in our program. We also have value comparison operators, right? So we saw here that we can assign to a variable a value with 1 equal sign. So this is an assignment. But when we want to check if the value of some variable is equal to whatever value we want to check, then we need to use 2 equal signs. Okay, 1 equal sign for assignment, 2 equal signs for comparison or value comparisons. Double equal sign means equal to. Exclamation mark equal sign means not equal to, greater than, greater or equal than, and the same with lower than and lower or equal than. And finally, we've got yet 2 more, well, one and a half more operators, which are the membership operators. It's still English, so we can safely assume that this is going to be self-explanatory. In and not in, but not comes from here, but if we put it here because it kind of makes sense to have them grouped together in one set of operators. For example, if we have a list of numbers, and we will see lists almost at the end of the webinar, with certain values, 1, 3, 7, 5, this expression is valid Python. Check if the number 5 is included or contained in this array of numbers, and this would return true. Okay, so far so good. And we've got a few examples here, right? So when you write more than one print statement in your Collab notebook or your Jupyter notebook, if you're doing it in your local machine. But when I say Jupyter and Collab, don't worry if this is new terminology for you. I'm basically saying the same thing. Collab is an online notebook that you can use which is exactly this, and you use it in the browser. Jupyter is the offline version, which you would have to use it, you have to install it in your machine. But maybe you want it because you may want to do some prototyping, do some programming without being online, may be the case. So back to this, as you can see, the output of this cell is 4 outputs, which correspond to this line, this line, this line, and this line. But these assignment lines or any other line that doesn't generate an output, they will not be printed out. So this is the results only. The result of running this cell is only going to correspond to the print statements. First print statement prints the result of 4 plus minus 10. So nothing special here. 10 modulo or reminder of 2. So this basically means divide 10 by 2, and if there's no value left, then the result would be 0. And that's the case because 10 divided by 2 is 5, and it's a round division. In Spanish, this is called resto, so it kind of makes sense, not the rest, which is actually not 0 if you do 10 modulo, the modulo of 3, which is 1, because 10 divided by 3 is 3, but there's a value of 1 as a reminder. Here we assign two variables, x equals 10 and y equals 3 to the power of 2. So then the first operation that happens is the multiplication. So 10 times 9 is 90, and then the subtraction of 9 is 81. Okay, so this is not really Python, this is math, but enough to get us give us a little bit of exposure of the cool stuff that we can do with Python, only with operators. I mean, we haven't even left the terminology section already, and we can already do quite a lot of cool stuff. Operators, done. Operands, they are the values an operator, this is typo here, these are the values an operator is applied to. For example, 1 and 2 in the expression 1 plus 2. For example, x equals 1, that's going to be one operand. Y equals 3, this is going to be another operand in this expression. So you saw before that we could seamlessly do a string of text plus a string of text here plus a string of text here, and no complaint by Python. And you've seen that we can do, let's run this cell, we can do number plus number equals the sum of the numbers. Okay, so that makes sense, right? So one thing I wanted to say, Python is a dynamically typed programming language. So what does that mean? This means that we can, and I'll explain a little bit more further down, but now we kind of need to stop at this. This means that we can change the value of a variable as we go along. So we can say that x equals 10, and then we can say that x equals hello, and Python will not complain. So Python allows us to be quite flexible with how we deal with the types of the variables, but it will not always allow combining values of different types. Sometimes it will, sometimes it won't. Sometimes it's not really intuitive why some things are allowed and some things are not allowed. Let's say y equals summer. I had hello, but let's do summer, right? So I already hinted here that this is probably not going to work. So this is our first Python error. I mean, this is, okay, so if there's anything intimidating in programming, is the errors, especially if they are hard to interpret. Here, what Python is telling us is that there's a type error, and it is pointing us to the line where the error happens. Okay, so it's printing the context, the two lines that go before, and this is the number, the line number. For the, for a notebook, it doesn't really make too much of a difference, but if we were dealing with thousands and thousands of lines of code, it's very convenient for the error to tell you, hey, you should go to line 512. And it's telling you that there's an unsupported operand for this there's an unsupported operand type for this operation. So we first have an integer, and we will see now a little bit later what an integer is, but basically it's a number. It's a number without decimals. It can be negative, it can be positive. Int stands for integer number. And str stands for string of characters, like this guy here. So Python says that you cannot add a number and a string. And you probably are thinking, well, that makes a lot of sense, right? Why? What would ever be the result of adding a number of a string? It doesn't make sense. Now, would it make sense to multiply them? based on the same logic, it shouldn't make too much sense. But lo and behold, Python does not complain about this. Okay, so that's why I'm saying that sometimes it's not really intuitive why some things are allowed and some things are not. So if you multiply a number and a string, what happens is that the string gets concatenated as many times as the number it is multiplied with. Okay, so long story short, there are certain things that we can do with numbers and strings of text and certain things that we can't. Okay, but this is fine. And this is an expression. An expression is a combination of the above, an operator, an operand, anything that after it's evaluated, after the computer has checked whether that is true or not, it produces a result, right? So with these operators, we've got here and here and here and a few values, we can already start writing some code that checks for whether certain conditions are met or not. For example, we can do, okay, x equals 0 and y equals 1. Now, I want to print the result of evaluating this expression. Okay, so x greater than y, it's not true because it's actually y is greater than x. Now, if I, and again, no, this may look super straightforward to you. X equals one thing, later on X equals another thing, different type. Where's the big deal? Trust me, in other languages, this would require much more programming because we would have to instantiate and then assign a value to the variable, and recasting or changing the type of the value is not straightforward in other languages. But fortunately in Python it is. So we've got X equals Luis and Y equals Cardiff, and we check whether X is greater than Y. And now it says true. So it's actually saying that Luis is greater than Cardiff. Well, I mean, beyond the metaphorical joke that comes out of this, what's happening here is something called the lexicographic comparison. In fact, Luis is not greater than Cardiff. But what Python is doing, it's comparing the first string, the first character of both strings, and it's checking for the order in their position in the alphabet. And the one that has the earliest position in the alphabet is given the lowest value. So because L has a higher value in the alphabet, X is indeed higher than Y because L has a higher, the position is the position number is higher than for C. But what would happen if we had two variables with values for which have the same starting letter? Well, Python would move to the next one and then would check whether this one is greater or smaller than this one. And here we can see for the evaluation, X is greater than Y, not true, actually false, because the Y comes later than the U in the alphabet. And indeed, X equals Y is false because Luis is distinct, is not equal to Lyman. And as a final point, I just uncommented. So do you see what I did here? I had this pound sign, I think it's called in English. That's something that Eric told me in some days ago, but I just forgot. I keep calling this the hashtag sign, but you know what I mean, this little thingy here. So this is what we use to insert comments. So lines of code that are not evaluated by Python. I had this line commented, but now I have uncommented it and rerun the cell because I want you to see the error. So this line of code doesn't work. And there are a number of reasons for this. This is a case where the error is not very self-explanatory. What's happening here is that this is an assignment operation. This is not an expression. This is not something that Python evaluates and then returns a value. This is just saying that X now has the value of Y. But you cannot print a assignment. This is not something that you can print. It just happens. So even if the error is not exactly telling you this is what's going on. Whereas the previous line effectively prints a false output, but the compiler is not complaining. Okay, good. And finally, statements. So these are instructions that the Python interpreter can execute. So this is the actual language that the programming language understands. So the Python is going to behave in one way or another, depending on whether certain statements hold or not. For example, if A equals 2. So this is a conditional statement. Okay. Let's look a little bit more in detail into this. We already saw a little bit of a hint of a list, a little bit up. Where was it? Right here, right? So I said that we could have an expression like this with the membership operators, where we checked whether the number 5 was included in a list of these numbers. This is the same thing, right? This is a list, which is it's a Python type. So it's not like we're naming it a list because it's the English word. It's because it's the actual Python data type for this thing here is list. And this is a list that we assign to the variable called fruits, where we have 1, 2, 3, 4, and 5, 4 fruits. Okay, banana, kiwi, apple, and pear. And we have a new item called carrot. Now let's print the result of checking whether the new item is in the value assigned to the fruits variable. And then let's check the reverse. Okay, so new item in fruits, that's false. The reverse, new item or carrot is not in fruits, that's actually true. Okay. We've come here to our first conditional statement. So even if this is not something that we're going to cover extensively today, it makes sense to talk a bit about it. And there's one main reason for this. You see, sometimes I mentioned, no, you've got some block of code that gets executed depending on whether a certain condition is met or not. But how do you know which code gets executed when? So you need to tell your program where does it start and where does it end. So what's the scope of the code that runs when certain condition is met? In some languages, you denote this scope with certain notation, like for example in Java with curly braces. So you would do this. This code happens if something is going on, and else this other code. Yeah. No, so I mean the syntax is not exactly like this, but if something happens, right? So, and then you would wrap whatever computation you want to run inside these curly braces. But because you're using curly braces, this is just this thing I just wrote is only a readability measure. In fact, I could do this. Because for the program, it doesn't really matter whether you're using the same or different lines, as long as you're following the conventions for isolating inside the same scope certain computations. Now for Python, that's not the case. Python wants things to be explicit. And what does that mean? It means that you will not see curly braces in Python. Python will expect you to use indentation to refer to blocks of code that run conditionally. Now, indentation meaning taking some line of code and moving it a little bit to the right. It's flexible how we want to do the indentation. That's totally open. It can be with 2 spaces, it can be with 4 spaces, it can be with a tab, 2 tabs. It's up to us. As long as we're consistent, the Python interpreter will parse or will read our program and will determine whether we've been consistent with the indentation we used and the different blocks that require indentation. And if that's the case, Python doesn't really care if you're using 1 character, 1 tabs, stroke, or 3. So you could, this would be a valid indentation as long as you are, as long as the indentation is consistent throughout the program. The default in Collaboratory is 2 spaces. Default in Google Colab is 2 spaces for indentation. And the consensus is using 4 spaces or 1 tab, right? So if you read Python code out there, it is very likely that it will follow this convention. But if you read a notebook that was written in Colab, because of how Colab works, you will probably see 2 spaces. And here we're sticking to the Colab convention because otherwise we would have to, reinvent the wheel, and it doesn't make sense. But if you read other people's code, it's very likely that the indentation policy that they're going to be following is 4 spaces or 1 tab. Okay, so this means that whatever gets indented under the if statement happens if this is true, or in other words, if this condition holds. Now, if this condition doesn't hold, this block of code is executed. So this is actually saying whatever happens, only one of these guys is going to run and not the other, because we have a binary condition. If else says that either whatever condition we have, that condition can only have 2 outcomes, either the first one, and if the first one is not happening, then the second one. I'm insisting a little bit on this because it could be different, right? So let's have a look at the actual if statement. We're checking if new item, which is carrot, is not in fruits. So indeed, carrot is not in fruits. So because this condition holds, then we would be running this line of code where we concatenate the value of new item, carrot, with the string is not a fruit. But if it were, then we don't want to print anything. Maybe we're happy with the overall workings of the program, so we print program is over, right? So let's actually check the opposite. Let's put carrot here and rerun. And now what happened was that this evaluated to false, and then Python went here and checked this guy. But you're not required to write an else condition in all your ifs. You can have an if statement. If something happens, you do this. And then regardless of the outcome of that if statement, my program can very well go on. It may be, I may want that. But if that's the case, it could, if we remove carrot again from the fruits list and we check if it's there, if it's not there, this is running, but then this line of code is not dependent of this guy here happening or not. They're totally independent. So this happens, but then this happens again. And the reason for this is this line gets executed always because it's not dependent on the result of the previous if statement. Okay? So actually, this was a reason for me to talk about indentation, but since we were at it, we said a couple things about if-else statements. This is linked to program flow, which is something we're going to focus on in the next session, not this one, because we still have a few things to cover today. Okay,